Hi everyone. This lesson is continuing on our theme about the distributive law, and it's another special case. It's the difference of two squares this time. So let me start with an example and we'll see what I mean. Imagine please that I had the following. I have a plus 3 multiplied by a minus 3. Now, it's not a perfect square, they're not identical, they're very similar. The first binomial term has addition and the second binomial term has subtraction. So apart from that, they're very, very close. So we can't use a perfect square system, but we could use our normal old distributive law. So we would end up with a multiplied by a, then a by negative 3, then we'd have a positive 3 times a, and a positive 3 by a negative 3. So let's see what that looks like. A times a is a squared. A times negative 3 would be take away 3a. Then positive 3 times a would be add 3a. And finally, subtract 3 squared is 9. Now I think we can see that the like terms here are equal and opposite, so they will wipe each other out. And we're left with a squared subtract 9. Now, why does this thing get called the difference of two squares? Well, because there's subtraction. Subtractions in mathematics are also called differences, and because 9 is a perfect square, so is a squared. It's a times a. 9 is 3 times 3. It is literally the difference of two squares. Let's see another example. We could have 2x plus 4, 2x minus 4. Once again, the first term in both of the binomials is the same. The second term is 4, and the only thing is that the first binomial is addition and the second binomial is subtraction. Now we could multiply it all out, or we could use our pattern. What did we notice with our pattern? We noticed that the first term ended up being squared, a squared. The second term, 3, ended up being squared to become 9, and it was a subtraction between them. The two middle terms, the like terms, ended up being equal and opposite. The same thing will happen here. Now we'll do this one out in full. We'll do first by first, first by second, second by first, second by second. Let's see that the same thing happens. 2x by 2x. 2 2s are 4, and x by x is x squared. Then 2x by negative 4 is negative 8x. Now the 4 times the 2x this time is a positive 8x. Then negative 4 times 4 is 16. Yes, again, the two like terms are equal but opposite. We have ended with 4x squared, which was the first thing squared, 2x squared, subtract as a difference, and then 4 squared. 16. Again, the difference of two squares. So we can use this as a shortcut pattern. Let me write the rule out. The rule would be a plus b, a subtract b. And immediately, we recognise the first part is the same, a, the second part is the same, and one is add and one is take. It'll be the first thing squared, subtract the second part squared. We don't have to do the whole distributive law and then cancel the two terms in the middle. We can recognise this now as a special case and use the shortcut rule. Let's see one of these in action. If we had, let's make it a nice one. It could be 7xy squared plus 3x. Now the first part, 7xy squared, would have to be the same, and then it would be minus 3x. So let's use the rule. We see that it is a difference of squares because the two terms are the same, one's add, one's subtract. So 7xy squared has to be squared. 7 7s are 49. X by itself is x squared, and y squared squared is y to the 4th. Has to be subtraction, it's a difference. Now 3 squared is 9 and x squared is x squared. And we have the answer immediately. much, much easier than applying the full distributive law. Okay, that's it for difference of squares. Thanks for watching.